Right, this webinar today, welcome everybody. So there's quite a few people attending from all over the world, so whether it's morning, afternoon, lunchtime, whatever, then hello. This is really about how we at MMT have implemented the FMBIS, but I'm also going to explain what it is and how it fits into the QPS product range. So I'm going to cover what it is, and in my opinion I'm going to cover why we need it, and then explain a bit about what the BIS looks like, how it works, and then the nitty-gritty of how you actually input data to the BIS, and then using the BIS for other work, and how we use GIS in general, because this is one of the main features really is you're actually in ArcGIS, so what you can do with it is really, I wouldn't say unlimited, but it's certainly, there's an awful lot you can do with it. So ArcGIS for maritime, this is basically what FMBIS is, and I'll explain exactly what it is in a moment, but Esri have two products that come under the ArcGIS for maritime heading. One is charting, and the charting is all about creating, maintaining and publishing nautical charts, so that's aimed at hydrographic offices and port authorities. And the bathymetry, so the ArcGIS Maritime Bathymetry, is really storing the bathymetry data and then using that and modeling multiple surfaces together, and some very advanced but simple to use tools that are in there. So what is FMBIS? Now QPS are an OEM reseller for Esri products. That means that QPS can sell certain products, but they can't call them ArcGIS. So FMBIS is basically the ArcGIS for maritime bathymetry solution. So this is the bathymetric database. And what you get with FMBIS is ArcGIS Standard, the 3D Analyst extension, and the bathymetry extension. Now QPS can sell you that as a bundle only. If you are already, if you've already got ArcGIS, and you so if you have, especially if you've got, say, an enterprise license, then you need to contact your Esri distributor or local reseller to order the bathymetry extension, because that's to run the ArcGIS for maritime bathymetry. You need those three. Well, you need ArcGIS Desktop Advanced or Advanced, and you need 3D Analyst, and you need the bathymetry extension. So if you haven't got any of those two extensions, then contact your Esri reseller. But if you haven't got ArcGIS, or you want to buy ArcGIS, then have it all bundled up, and like you need another license, then you can buy it directly from QPS in that bundle. And at the moment it's a really, really good time to buy, because there's an introductory offer, and it's €5,000 to buy those basic three products, which if you were going to buy them separately in normal pricing would cost you about €14,000 or thereabouts. So even if you just want another ARC license, it's worth buying this at the moment.
Duncan, sorry,
the
just
FM chart.
Duncan, sorry. Just can you speak up a little bit? I can hear you okay. Some people are having problems. If you're having problems hearing Duncan, please just try raising your audio. I can hear him okay, and I haven't had too many complaints. And but Duncan, if you can maybe yell a little louder, that would help. Thank you. Sorry to interrupt.
Yeah, sure. No problem. FM chart is the ArcGIS for maritime charting bundle. This has got more to it, because you have ArcGIS Advanced, you have all those other extensions below there as well, and again, QPS can sell you the bundle, but they can't sell you the individual extensions if you've already got some of them. So if you have some of them, then go to your local S3 distributor again. So they're the two products, and what I'll be talking about really today, because I'll just go back one. At MMT, we don't make nautical charts. We collect lots of data that go on to nautical charts, but we don't actually make the chart. We make a lot of maps, and a lot of deliverables are ArcGIS models or geodatabases. So we use the ArcGIS software a lot, but really we're talking about managing the bathymetry and then using that bathymetry data in our data set. So FM chart I'm not going to cover, but FMBIS I will. And why do we need it? Now this is a view of one of our servers, and you know, it doesn't tell you what the name of the survey is, the number of the survey. I can guess where some of these surveys are, but it's not really a nice way of looking at the data. And as a I think we're all spatially aware professionals in our as surveyors, geophysicists, geodesists, GIS guys. We have a very strange way of looking at our data just by throwing it all into servers. The other is I've got iPhoto on my Mac, and that's more spatially aware than we currently store or have stored our data in the past. This is the other issue. We have massive amounts of data. This is a server in Gothenburg. This is something in the region of 600 terabytes of data that are in there at the moment. We have about 300 terabytes over in the UK office, so it's an enormous amount of data, and really we have to have a good view of it and manage it well. And this is really the fundamental, when you're looking at how to manage bathymetric data, one of the things you have to ask yourself, or as an organization, is are we actually producing charts or are we producing maps? And what type of product do we need to create? Because we're not, there are other packages out there that you can get, but they basically just deal with bathymetry, and they just stop at bathymetry. But we have backscatter, we have geophysical data, we have seabed samples, geotechnical data. All of those things we have to produce, and we normally now have to produce it in an ArcGIS geodatabase. So really the option of what software choice to use for storing the bathymetric data is easy, because we want to be in one product, we don't want to be in two, and our products at the end are ArcGIS related products. So that's why we went for the ArcGIS for maritime bathymetry solution, or now FMBIS from QPS. The advantages of GIS generally, it's structured. You can scale it. We do installations, which we'll come on to later on, for large clients, from small single files to whole enterprise solutions. It can integrate with lots of different packages, and then we can also start to share this information as well in new ways to our clients. So so it's really useful in that way. So rather than just show you this is the spatial view of our data, or if I just kick in at the moment, this is the spatial view that we have in our data. So this is ArcGIS, this is ArcMap, and these are some of the data sets that we currently have in. So as you can see, you can click on these areas and zoom in, and I'll show you how the whole thing fits together. And this toolbar up here is the ArcGIS for maritime bathymetry toolbar. So all these different, just this small section here, that's what the BIS extension gives you. It gives you this toolbar. just wait for you to catch up on the screen there. So when you look at the survey areas, you can see the bounding box of where the survey actually is, and then the color map that's associated with it tends to be the color map for all the different survey areas that you've got until you actually want to do something with it. And within that, you can then preview different data sets when you come through. So these are looking at different metadata associated with the same data set. So the one on the left, this is looking at collection metadata, which I'll explain in a moment. There's internal metadata, which is the actual what comes in the file itself. And on the right-hand side is extended metadata, which you can configure all the metadata fields. Apart from the internal one, you can configure the other ones to be specific to your organization or to your needs. So how things link together for using the data is you have huge volumes of soundings which are being acquired at a rapid rate of knots. At MMT we have all three manufacturers of multi-beam echo sounder. We tend to have dual Kongsberg systems hull-mounted on the vessels. We have dual Reson and RT Sonic systems on our ROVs and our ROTVs. So they're all dual, they're all massive amounts of data, and we always use Fledermaus to actually process the data, to clean the data, produce a lot of the products, and now we're pushing that data from Fledermaus into the BIS system that we have internally, and then from there we're using ArcGIS to integrate with the BIS to then produce the products, and our products tend to be for oil and gas companies and for renewable energy companies in terms of those that are asking for ArcGIS. The surveys we do for the Maritime and Coast Guard Agency, they get stored in our BIS, but they are delivered as a full data set rather than a GIS deliverable. So the way that FMBIS works, or the ArcGIS for Maritime Bathymetry, as you register the data into the BIS, you can then explore around it in ArcMap and look at the metadata. Once you have an area, you then compose this into one surface, then add the features, and then from there you can share it either as another geodatabase or via ArcGIS Online or other solutions for sharing on the cloud. So, putting data into the BIS. This is where Fledermaus comes in, and I'm just waiting for your screen to update. So this is a survey we did off of Dover in the southeast of the UK. This is coloured by uncertainty from the cube algorithm. So this is a cube surface we're looking at. I've also got checked areas here as well, which is why you have this overlapping area. And then when you zoom in to one of the wrecks, which will be in a moment, you can see on top of the wreck there's a little white flag there. That's basically showing that this is a feature sounding and golden sounding. So this is the cube surface is pushed up at that point. Now the data when it goes into the BIS is a gridded data set. So this is the cube data set. The cube deliverable is a regularly spaced grid, and then you update the surface to make it fit the top of the wreck. So you're pushing the surface up to match the top of the wreck. Once you have this surface done, then the way that the format that you need to create is called a bag format, which is a bathymetric attributed grid. It's actually a very good storage format because it's a compressed binary file, so they aren't very big. And when you have your cube surface created here, then in Fledermaus you have the option under the Tools menu here to export a bag surface. And when you click on that, it asks you for a bag. I'm just going to call it bag for the moment. And then it comes up with the metadata fields to go into the bag itself. So you can call it whatever you normally you call it, the name of the survey and whatever else you might want to call it with it. This is all metadata that gets stored inside the bag file. So there's various other fields that you need to fill in, and what vertical datum you're using, and then you just press OK, and that stores this bag file down, and that's where it goes. You can also, and this is using the link between ArcGIS and Fledermaus. This is directly looking at a geodatabase I created, and what I've done here is with the have an ArcGIS tab, you can then say transfer those soundings. So what I've done here is taken the soundings for the entire PFM, just the accepted soundings, and then only just the feature soundings, and that way we have a record in a geodatabase of just where the golden soundings. I can also add into that database over here. I can transfer, say, the survey area, and if I want to, I can also transfer in the rasters of the bathymetry or the image that's actually there directly into the geodatabase. So this here is looking directly into this soundings geodatabase. Now, the next stage is loading the data up into the BIS. So I shall go to ArcGIS for the moment here, and what I'm going to do is just zoom into to an area. Which is just down here. And it's just using the ocean base map for ArcGIS. What we can do now is come up to our tabs on the top here, and if I look at the collections, this is now connecting up to our geodatabase. So this just makes sure that we have an active geodatabase here on the connection. And then I've already got a collection here. I'm just going to check the collection. So this is just retrieving the ones I have, and I already have one here called English Channel, or Le Manche, if there are any French people on the webinar. And this is one I did earlier, so this is just saying when we did the surveys, and so you can make these collections up based either on an area or on a specific survey if you've got multiple blocks you want to add in, and creating them is just as easy as putting the collection name in, saying whether it's ongoing or complete. Again, all these metadata fields you can change yourself if you want them to be specific to what that survey survey is. We want to add data to this geodatabase. We can then go to I have a bag file on here. So 1341A2 is our bag. I'll say yes that for the moment, just because I'm not actually going to push it in, but just to show you. And then if you want, you can click on that, and then you say, okay, what collection do I want to add this into? And the collection I'm going to put into the English Channel. So this is that metadata that we had before. And then there's another bit of metadata which you can change, and that's to say, okay, what IHO order is this? Order 1A. The sensor. This is actually a dual resonance CBAT 7125. The vessel is Explorer, and the data type is multibeam. So all those different things that I changed when I was going through, they can all be custom configured. It's just an XML file, and you just go in there and add things to it. And then the information down here, This is from the bag format. So when I actually created this bag file, the title of the bag file was this on the top here. I added in a little bit of extra information as the abstract, and this was the date I created that bag file, and it also gives the cell size of the bag file as well. So this is all within the bag format. At the moment, there is one minor issue with this, and that's to do with the way that the bag is structured. When you create the bag, it gives today's date as the day that bag was created. Now, that's not what you really want when you do this, because especially if you've got historical data, because one of the rules that I'll show you in a moment is that you can prioritize newer data from older data. So when you create your bags, if you do have historical data to do it, then the only way I found to do it at the moment, and they are meant to be changing it in Fledermaus to do it, but you can basically clock your computer clock back and do it that way. That seems to work. Fledermaus can do it. Arc doesn't like doing that. And then when you press OK, it will then load it into the database. To see what data is around, I can I'll turn this off for the moment. These are all the bags that are currently in my database, and I can if I just move, if I zoom out a little bit actually, I can filter to current extent on this, and this will look into the database, and it will just, wherever that is, it will just filter to those current extents. And then if I want to see where everything is, I can preview that information here. And then what this is doing, then building the overlay and the overview for these different areas. So these are the areas that were within that area, and this is the area outside of Dover that I brought in. And that's really as simple as it gets to bring it in. One of the things which is also very nice about this is we haven't actually, doing this, I haven't actually brought anything in to the ArcGIS database at the moment. The bags are located on our servers in each project folder. So we're not replicating any data here, because what I definitely didn't want to do is to add more to the volumes of data that we currently have. So you store a bag file within the database, in your server, within just any file location, along with your process data or your Fledermaus scene file or whatever you store with it, and then you just link to it. And when you bring it into the BIS system, like I did, it stores the various overview layers for zooming in and out, but you're not actually bringing it into the database yet. If I just turn that one, go to unfilter my data in a moment, and I'm just going to go to up here in the ArcGIS, and I'm going to filter my data to this extent. Let's preview this. This is some of our Maritime and Coast Guard Agency surveys up in the Orkney Isles. So this is about it's probably about a year's worth of survey acquisition. I can't remember how big an area is, but it's probably about 3,000 square kilometres of survey. So quite a large area. And in here you can zoom in and out. It's pretty quick at pulling in the different views and areas. But one of the things with the BIS, and this is where when you end up in ARC where it really works well, is that when you want to actually compose the surface. So what I want to do now is to say, okay, well, I'm going to build one continuous surface from these individual files here, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different surveys in here. So if I add these data sets to a continuous surface, let's just move that over. And this is a composed surface view. So when you add this, you can do this in a number of ways. So there's a rule here, so I can say, okay, well, I'm going to add a rule. And one of the rules I can have is, okay, end date, say. So this will where there's overlap between the surveys, this will prioritize the latest survey over the older survey. Normally the technology improves, so you'd want the newer one to be better. You could also say, okay, well, I actually want to do it based on the sensor. So, this is where you can take the data and say, okay, well, the 2040 is definitely more accurate than the 3002. And then, say, the 7125 dual. It's going to be controversial here. I'm putting it below the 2040. Don't shoot me. And you can change the priority here. So the first bit will be it will take the newest. But then if it finds or you can use either, and then it will take the highest resolution sonar. So these rules, and you can save these rules, and when I save this surface model, this is when I can create a geodatabase. And when you create one geodatabase, then you can do all the normal rules and tools that you can do with ArcGIS. So for instance, I ran contours in Arc over the entire database, which is just one database with this combined surface. The combined surface will also be multiple cell size as well. So if you have like a 1 meter DTM and a 4 meter DTM in here, it will prioritize. One of the things you can do is prioritize the DTM over the top of it. So I need to move that up so you can see. And it was quite quick. It took about 15 minutes to do these contours, the 10-meter contours, I think, over the entire area. And it took about the same time to actually compose the surface. So it's a very powerful tool. And if you're doing pipeline or cable route surveys, you can just create one massive surface for the whole area, and then do slope analysis on it, the contours on it, and then once you have these, you can then reference to them and build the products around it. So this is just a recap. So we make the bag file from Fledermaus. We then either create the BIS or create a new collection before we add the data in. And then we take the bag file, just waiting for your screen to update. We take the bag file, we associate it with a collection, we associate the metadata for that particular file, and then that launches it in. One of the things which this example of is just viewing by vessel. So we had a survey in one area which had 4 different vessels, and you could see all of them together. If you just wanted to look at, say, Ping's area that she covered, you can just show just that one vessel. Over here, where it says vessel, you just say, oh, I just want to see this one vessel. And then when you combine the surface, this is when we use this one in the Orkneys. I just did it as a latest survey wins. It creates a mosaic data set from the model, and then it builds the overviews for that particular mosaic data set. So that's the one big huge surface, and then you've got all the Arc toolbox stuff here. And some of these GP tools, geoprocessing tools, they're in the process of having actual Fledermaus commands being generated from Arc itself. So the bathymetry tools will include a lot of Fledermaus tools, so, which would be kind of neat. And I'll stop there for the moment. So if you've got questions, then and I can see Bertrand's here as well. So if he gets technical on the Arc side, I'm going to hand over to Bertrand. But stop here for questions before going any further.
Hey Duncan, great. I'm going to scroll through my questions here and bring up some of the ones that you'll be able to address. And if you did address them, please excuse me, I was busy typing, trying to keep up with the stuff coming in. So let me just see a second. Can you address the cost issue again? Some people were asking, and I wasn't sure if it was euros or pounds or what. So can you just repeat that?
The cost at the moment for FMBIS is 5,000 euros. So that's ArcGIS standard, the 3D analyst extension, and the bathymetry extension.
There was some questions from people who are more on the processing side of thing, and they weren't quite sure. Some people said, oh, I didn't know Fledermaus could do tides and all of that stuff. So can you just clarify that portion if you're coming from the processing end?
To get to the cube surface view we're looking at is on top of the pure FileMagic, the PFM data structure that is in Fledermaus. So that PFM data structure is created by having data sets in some form of XYZ format. So pretty much every single processing package you can read into Fledermaus. Of course, the quickest way of doing it is with Quincy from the processing manager, because that's, since the merger with QPS, that's the link that we've been working most on. And in processing manager you can to do tides and sound velocity correction and things like that. So otherwise, if you're having some of the other software packages, then do the tides and the sound velocity there. So you have it in X, Y, Z, and then, or X, Y, Z, depending on which side of the Atlantic you're on. And then from there you do all the data cleaning and cube generation and cube editing and things. You do all that in Fledermaus.
Okay. This question just might involve some clarification about, again, what the BIS is and things like that. But are you able to map the fields from BIS to feature class fields, or load them directly to specified FCs, I guess that's feature class fields, in the SSDM?
The SSDM I'll cover in a moment. The difference here is that the BIS is really not about a geodatabase until you combine the surfaces to create one, or you just have one surface and create a Bathy geodatabase from it. The SSDM has many more features and many more types of data that are in that single geodatabase. So the main thing for the BIS side of things is you're creating bags. ArcGIS is linking to those bags, creating the overviews, and the overviews are what you see in ArcMap before you do the composed surface. So you're not actually dealing with a geodatabase until you go onto the composed surface option and use that. So I'll come on to the CVS survey data model and what it looks like in a moment, but that's the main thing to sort of bear in mind with the BIS. It's not a geodatabase. It's a bag with references to the Arc. In fact, when you fire up, what I haven't really shown is when you fire up ArcGIS, when you have a BIS connection or BIS connections, when it opens up, it's actually making that connection when you open the program. So you're not necessarily looking at anything, it's just making the link. A bit like mapping a network drive. It's making the connection so you can use it.
Okay. If you click the View Metadata XML button in the Add Bathymetry wizard, can you edit the bag metadata?
You can't edit the bag metadata because the bag metadata is written into the bag when you create it. What I think is being developed at the moment is a bag metadata editor. I mean, the problem is the bag format specification is designed so that it's made once and once only, and there's a bit of security in there. But obviously, like for the if you get something wrong, or if the date's wrong or whatever, then it would be very useful to be able to change it. So there should be a way of doing that shortly. And
okay.
that might be from ArcGIS as well. I'm not sure.
Just a note to everybody, I don't want to take up too much time with questions, but right now Bertrand's answering a lot of questions directly via text, and he's answering it to all. So you guys should all be able to see his answers, and that will save us a little bit of time. while we're going through this. Duncan, why don't you continue on, and I'll try and rally up the questions, and at the end we'll cover the ones that cover the most relevant topics for everybody.
Okay. So what I'm going to go on to now is how, once we have the data available to ArcGIS, how we use it. And this slide here is really to show you that nearly all of these client segments here, market segments and clients, need an ArcGIS deliverable. The ones that don't at the moment for us are really the hydrographic market segment, because most of the time there the data is going to a charting authority and they will do their own validation and everything before it goes onto a chart. So so that's but for the environmental side of things, oil and gas with the seabed survey data model, the renewable industry in Europe anyway, is starting to use the seabed survey data model, but definitely is using ArcGIS, from the start, if you like. Oil and gas has traditionally been a very CAD, either MicroStation or AutoCAD dependent environment, and it's slowly, well, quite fast at the moment, migrating away from that, which is really good. And so with cables and the environmental side, again, we are finding more and more that we need to provide an ArcGIS solution as part of our deliverable. So what we've attempted to do at MMT, and what we're trying to improve on all the time, is our workflow. And with the developments at the moment at QPS with Quincy and Fledermaus, then the front end collecting data to process data should be pretty seamless, and the idea is really that you start logging in Quincy on the boat, and that's the last time you actually touch a file format as such. That we will maybe to make a bag at the end, but the way that it works is we're taking the data and we're putting it directly into a geodatabase, and that's also backscatter as well. And seabed text to sheets and things like that. And then once it's in the geodatabase, we then expand it out to produce the products that we need for our clients, which might just be a replication of the geodatabase for some. It might be an AutoCAD product for others, or a combination of the two, which is also quite often. Or it could just be a XYZ ASCII data set. Either way, the workflow for these surveys at the moment is to go directly into a geodatabase, and from there we go out, rather than going, okay, I need to make an AutoCAD drawing, so I need to change things. Because the other big advantage about doing it this way is that we only have to make one change once. If you find that the pipeline route changes and you've already done all your alignment sheets, then you've got to change every individual alignment sheet if it's in a CAD environment. Whereas in ArcGIS, you just change the pipeline once, and that's it. It's done all the way through. So this is what we're trying to achieve, and with the geodatabase, what I should also really put as an aside to that is also the BIS is sort of there already, so we're sort of linking the BIS into the geodatabase. So these are some of the standards that are currently existing at the moment. There's the OGP seabed survey data model. There is an ArcGIS pipeline data model, which we're hoping will expand out so that the whole 3-box chart becomes a thing of the past. And then the ArcGIS marine data model is just something which we don't come across very often, but sometimes in the habitat surveys it's more of a scientific marine data model than anything else. But sometimes people choose it. And these are really templates, blank templates with different features, and certainly with the seabed survey data model, the idea was that it's a standard deliverable from any survey company. So the contours are always to be found in the same place and things like that. The actual SSDM is really a vector and a point data set. We've added other bits in addition to that, but the actual SSDM is more about the metadata, well, the features and things like that as lines and points. So this is an example of a recent SSDM in Arc. In fact, what I'll do is just fire it up at the moment, and then I'll just wait for my screen to catch up a moment. And so this is what it looks like in Fledermaus, and over here we have the different products that we've created. So we have backscatter here as well. So draped backscatter in here. We have these seabed features. We have the lines on the pipeline here on the just at the bottom part of the scene, and then over here we have an Arc workspace. So this is a create add ArcGIS workspace, and what this is really creating. You can have up to 10 of these different workspaces, and this is creating either a connection to a geodatabase, or you can create a geodatabase. And what I've done here is just create to it, and then if you down here, this is the seabed survey data model that we're looking at. Say the rasters in here don't go into, there's no feature class for those within the seabed survey data model. But these are the actual ones within that seabed survey data model. And what we can do, so if we have the contours, for instance, that we create here in Fledermaus, I can go to my ArcGIS box and transfer these as contours. And you can then look in here. This brings up the geodatabase. We find our bathymetry contours. You use the insert option, and then we do next, and then that sends that data into the geodatabase directly. So it's a very simple thing. There's a couple of limits at the moment which will be lifted shortly. One is that the lines and model formats in here for like the feature lines and points on the seabed and things, the insert function isn't in there at the moment. For those ones that, for now we create a blank geodatabase with those in, and then use Arc to copy those particular features into the right place in the seabed survey data model. But shortly in Fledermaus we'll be able to, I've been told, to add that functionality into here, so we can insert to any of these options in here. And it really is a very quick, very seamless way of doing it. And then in here, we have the. If I just close my Explore window for the moment. So over on here we have the same contour lines, the seabed features, and we also have the rasters as well. Bearing in mind from Fledermaus that we can always bring data from Arc into Fledermaus. So if you have field data from before that you want to use in Fledermaus to see what you're doing to help you process and things like that, quite a lot of what we do, you can just click on, say, the contours here, and then you can load them directly into the scene, and then that will say bring that in. But anything else in here, if I field limits and stuff like that, I could bring them in as well. we'll just go back to So that's the seabed survey data model, but also bear in mind with that the digitizing of the seabed texture areas, the lines, all of that can be done in Fledermaus. So you're not having to go to another product. You could also do that in ArcGIS as well, but so you're always maintaining, you're always in the link between Fledermaus and Arc all the time that you're doing this. The example I got here is from one of the wind farm surveys that we do, and now you're talking about something else which is really using the power within ArcGIS to the full. So once you've got the bathymetry is like your bedrock to everything, sort of excuse the pun, but that's where everything is held together with the bathymetry. But you've also got the backscatter from the multibeam 2. You've got your seabed grab samples, all these things, and then this is then showing the particle size analysis over different areas of the seabed. You've got all your old cables which you might have in a geodatabase already or not, various other sides of it. So you're really pulling together every conceivable instrument that is on board that boat and a bit more into the one final product. So the way that this, I mean, the great thing about this is that you can use the GIS as the hub for everything, and really the only way, there's only really one product out there that does that, and that's ArcGIS. So that's where we sort of, that's the whole reason for doing all this stuff. And just as an example of some of the ones that we've done for our clients, I mean, we actually host the database for, we don't actually host it for Nord Stream, it's in their office, but we maintain it. And that's a big enterprise solution on an ArcGIS server, and the entire database for both the pipelines and all their the pre-surveys and all of that stuff. There's a lot of 200,000 unique seabed objects along it, and it just keeps you just keep updating it. It works very well. And then one of the things we're looking at the moment is that when everything is in a geodatabase, there are a number of different web-based solutions that you can use to distribute data both internally and externally. So ArcGIS Online is obviously one of them, and you can make it so that it's only accessible to your clients and yourselves. You can make it just internally accessible, or you can also make it publicly accessible too. And this is all, and the easy thing with this is it's just pulling on what you've already got within inside ArcMap. So anything you create there, you can publish onto here. So it's a very simple thing, and you can also just go online yourself at the moment. And this is I just went on there just before we started today, and this is ArcGIS Online. You've got the UK, you've got from the British Geological Survey, you've got some of their bedrock and superficial geology, and they've also found there's some UK continental shelf fields and blocks and dune licensing and things. So it's that information is all already there and already used, and you can just make your own maps up and share it. So this is going to be quite key, really, I think, for the next few years. People are used to using Google Maps and things like that on their own at home, and they expect to be their products professionally that match it, and it's up to us as survey companies to provide those products to meet their expectation, which means the software's got to keep up as well. So just to conclude, really, it's simply a better way to store your data in the BIS, regardless of what you end up doing with it. I mean, being able to look at when you collected it, what boat it was, what system was on there. We're also going to link in like the reporter survey to it. maybe the wind conditions that were there during the survey, and the weather, we're collecting that anyway, so then we can then use that for tendering later on, so sort of completing the loop. The data is always there whenever you have ARC. You don't have to use it, but it's there if you want to use it, and then you can add to your products. And really, you know, it's no good just stopping at bathymetry. This is not just a bathymetry solution. Esri have said that they're going to be, you know, in time there'll be, you know, it won't just be a bag format. You know, it could be any type of sort of gridded data format. So your mosaic, your backscatter mosaics and things like that can be stored there. The actual scalar is what it's called in Fledermaus, so that's the X, Y, and amplitude, or X, Y, and, you know, backscatter roughness. Any of these things can be stored there, and then you can do the geoprocessing tools to say, okay, show me when the slope is less than 10 degrees and it's got gravel, because that's where adult scallops are living, sort of thing. That's what you need to, that's where we should be going with the data, and at the moment our clients are driving this as much as anything, because they're specifying things like the seabed survey data model and geodatabases. So it's you know, the GIS side of things is really pushing this way, and by linking Fledermaus and ArcGIS as a user, it makes it really simple to produce a lot of these things. And with ArcGIS itself, then you've got all these other you know, fantastic functionality that goes with it. So, so that's me done. More questions? I'm sure there probably will be.
Oh, there's so many questions. It's 10:56. We'll spend a few minutes addressing questions, but again, if I don't get to everybody, I promise you we will follow up with you. To start off, while I organize the questions a little bit and write some notes, can you just briefly explain again? We had some people come late, I think, and this webinar got a wide distribution, so not everyone is a Fledermaus client. So can you just straighten out like that, you know, Fledermaus is standalone, ArcGIS is standalone, and how they're standalone, but how we work together?
Okay, for the BIS, the bathymetric database part of it, Fledermaus is a standalone data processing and visualization package. It also does things like backscatter processing and water column processing too. You create a bathymetric attributed grid, a bag. This is an open source format gridded data set designed for, it's designed for navigational charts, is what it's originally designed for, and it's the X, Y, Z plus the uncertainty. So the uncertainty is a little bit like the standard deviation, so it's how well the data fits together, basically. And the higher the uncertainty, the worse the data. So that's a sort of a standalone product like an Esri ArcGIS grids, for instance, or you know, any of these sort of standalone gridded data sets. ArcGIS then links into this bag file, takes snapshots of what it looks like, and links to where it is, and then incorporates that in the views in ArcGIS map or ArcMap, and then when you actually use it, it then creates a geodatabase to then do the processing from and the products from.
Okay, thanks for that. There were a lot of questions about. Yeah, hopefully. There are a lot of questions about bags because we have such a wide selection of people here, and you did just a pretty good job of explaining what a bag is, and a bag is an attributed grid for bathymetry. There were some questions, is backscatter information included in a bag, and you can address that, and also is, for these people who aren't using bags, why they might start seeing them become more popular, more available, or what Esri is going to allow beyond bags as far as other raster formats. Can you address any of that?
Yeah, the bag is just bathymetry at the moment. I don't know whether there's any. I think there are. There's certainly ongoing discussions. There is the people that maintain, there's a collection of organizations and companies that sort of not control, well, they sort of control it, but it is open source. Open Navigation Surface Group, Open Navigation Surface. If you go opennavsurface.org, I think is where you find more information on a bag. And at the moment it's just bathymetry. If you want backscatter, then from either FMGT, which is the Fledermaus backscatter processing tool, you can actually go directly to an ArcGIS database from there too. So you just put it in as a raster or as an image. So if it's a raster, it's X, Y, and amplitude, and if it's the image, it's whatever your mosaic image looks like in RGB. So that's how you get both of you use both of those. I've forgotten the last part of that.
I forget too. We did have a question. This was kind of more down the lines of someone's actual workflow, but again, kind of touching on bags. How do you see the path outline getting from large HDCS data sets? And for those who don't know, HDCS is a ungridded file format that comes out of a software product called Keras. How do you see from getting from large HDCS data sets to the bag? Do I need to go all the way to a PFM, or can I create a bag from DMagic already? If you can just outline the options there, Duncan, that would be helpful.
Yeah, the one thing I haven't, the one I showed you was if I go to, I can probably do this on this scene file actually. If I take one of these DTMs, for instance, there is an option in the Fledermaus Tools menu. So if you already have a gridded dataset, it's not PFM, you have it as a gridded dataset. The bag needs to have the uncertainty, so you can't just go X, Y, Z, make it into a bag, because the software will come up and say there is no uncertainty with this surface. So what you can do is there's an option here to tools calculate IHO uncertainty, and this will just use you just sort of say, okay, well this is actually an ROV survey, so it's not even vessel mounted, so it's IHO, special order. It's quite, it's a 20 centimeter grid in places, so it's quite high accuracy. And then you can attach. Then it will use the uncertainty, the IHO. Like there's a formula which calculates what the uncertainty should be at that particular, the accuracy of the depth data at that particular depth. And you just create that, and that makes it into an XYZ with uncertainty, and that allows you to export to bag. So the tools calculate IHO uncertainty in Fledermaus. If you had HDCS data, you could grid that in Fledermaus to create a DTM, and then you could attach this IHO uncertainty without going through a PFM. If it was clean and you were happy with it, and there were no problem spikes in the data. If you had older gridded data sets that you already had, you just make an SD file of it, import gridded data from Fledermaus, and then do this tools, and then that adds on the uncertainty layer too. So I think in the future, and Bertrand will probably correct me or not, but the idea is you don't it doesn't have to be a bag, but what you would lose would be one of the rules to create a combined surface is the most accurate data is the one that wins in an overlap situation, and that's based on the uncertainty. So if you didn't have the uncertainty, you wouldn't be able to use that rule. You would just have to say use the newest, or use if you had the multi-beam in there as well. So you lose information, but in theory, in future, it would be possible to do that.
Okay, great. Thanks, Duncan. A lot of the questions coming in are about other formats, other companies and stuff, and I think Duncan's kind of been repeating that, like, if you have a bag, no matter if it comes from us, from Keras, from wherever, it can go into the ArcGIS Bathy solution, and that other formats will also be going in. But I can't, I don't think either of us can address like every format and software company, but I will try and should follow up with more of that. It is 11:05, so I am actually going to stop the webinar now. There are still other questions, and I will follow up with you all after the webinar. And my goal will be to also make available a spreadsheet of all the questions that were asked and answers either that were provided by me or Bertrand while we were online, or answers that I provided afterwards. So I will try to make all that available, as well as the recording. And you can email me. I have a good feeling that we will post this one on the QPS website, so you can keep an eye out there as well. So I am going to sum it up. Duncan, do you have any final statements?
No, not really. Just it's a good time to buy. The offer apparently is not going to be on for forever. So even if you just want a new ARC license, it's stupid to buy the FMBIS than it is to buy anything else at the moment.
Good way to sum it up. Thank you all again for coming. This was a huge turnout for this webinar, and we're pretty excited about it. So thanks again. All right, so I'm going to sign off. Thank you all, and have a lovely day, evening, or whatever, for whatever part of the world you're in. Thank you.
Thank you.